Let me paint a picture for you. Imagine a factory floor, a place where machines carve metal with a precision thinner than a human hair. In this world, a tiny, tiny error isn't just a mistake. It's a catastrophic, multi-million-dollar failure. Now, what if one of these high-tech centers just descends into chaos? Perfect parts are being thrown out, and faulty ones are getting the green light. Today, we're diving into a real-life measurement mystery, where the key to solving it all wasn't some new supercomputer, but a simple piece of paper.
All right, here's how we're going to crack this case. First, we'll get our heads around the basic rules of precision measurement. Then, we'll expose the mystery that was plaguing this factory. After that, we're going to hunt for the culprit, reveal the shockingly simple solution, and finally, look at the results, which are, frankly, incredible.
So, to even begin to solve this mystery, we've got to understand the two fundamental pillars of any reliable measurement system. Now, they sound pretty similar, but trust me, the difference between them is absolutely critical.
Okay, first up, we have repeatability. Just think of an archer, right? One person shooting arrows at a target. If all their arrows land in a nice, tight little cluster, well, they've got high repeatability. It's all about one person's consistency with one single tool. Can you get the same answer over and over again?
Then there's reproducibility. So now imagine the entire archery team is shooting at that same target. If all of their arrows from every single person land in the same tight cluster, now that's high reproducibility. See the difference? It's not just about one person being consistent, it's about everyone being consistent with each other.
So here's the bottom line. Repeatability is all about your own consistency. Reproducibility, that's about the team's consistency. And for a measurement system to be worth anything, you absolutely need both. If you don't have them, you get chaos.
And that brings us to the scene of the crime, a state-of-the-art precision machining center. I mean, on paper, this place was flawless, but in reality, it was facing a massive, incredibly expensive problem.
You have to understand, they had everything going for them. Highly trained professionals, the best machines money could buy, all perfectly calibrated. Even a lab kept at a constant 20 degrees Celsius. And despite all of that, a part that was approved by an inspector on Monday could be flat out rejected by a different inspector on Tuesday. It was causing total gridlock and completely eroding trust in their entire system.
So the investigators, they started to wonder, maybe we're looking in the completely wrong place. The parts seem fine, the people are experts, the machines are perfect. What if the problem was the very act of measuring itself?
To find out, they turned to an industry-standard report card. It's called a Gauge Repeatability and Reproducibility Study, or Gauge R&R for short. It basically gives the whole measurement system a score. Think of it like a grade in school. Anything under 10%, you get an A+. But anything over 30%, that's an F, a complete and utter fail.
And when they ran that first test, the results were just shocking. Their fancy, sophisticated CMM machine scored a 30.3%, officially unacceptable. And their 2D height gauge? It was a staggering 70%. This wasn't just a small issue. Their entire measurement system was fundamentally, totally broken.
Okay, so now they knew for sure they had a problem. The real investigation could begin. They had to go on a hunt for the source of this huge variation, this ghost in the machine that was creating all the chaos.
And you know what they found? It wasn't one big single failure. No, it was more like death by 1,000 cuts. It was 5 small, seemingly harmless differences in how each inspector did their job. One person might use a slightly different probe. Another might clamp the part at a different angle, or just place it differently on the table. And here's the kicker. None of this was written down, so every single inspection was a unique, unrepeatable event.
And this is where they had their big breakthrough. The solution wasn't going to be some million-dollar machine upgrade or a fancy new piece of software. Nope. It was something radically, elegantly simple. A checklist.
So the team proposed creating something called a standardized setting sheet for each and every measurement. The whole idea was to create a single, official recipe for how to inspect a part. This would guarantee that every inspector on every shift did it the exact same way, every single time, no exceptions.
And here's just a little peek at how it worked. This sheet, it locks in every single variable you can think of. It tells you the exact machine to use, the specific probe to attach, which clamps to use to hold the part. It even has photos showing the one correct way to orient it. It just completely removes all the guesswork and all that variation.
So,
The million-dollar question: did this simple piece of paper actually fix a massive, expensive problem? Well, the data speaks for itself.
The results were, well, they were breathtaking. The CMM machine's score plummeted from a failing 30.3% all the way down to an elite 4.77%. And the 2D gauge, remember, it was at a catastrophic 70%. It dropped to a world-class 7.42%. Both of them were now deep in that A+ acceptable range.
I mean, just like that, they had transformed their entire system from total chaos to perfect control. The mystery was solved. But the study revealed one final, completely unexpected and incredibly valuable bonus.
It turns out, by giving inspectors a clear, step-by-step recipe, they didn't have to waste time trying to figure out how to set everything up anymore. The new, radically precise process was also significantly faster. They improved quality and efficiency at the exact same time. It was a total win-win, saving them tons of time and money.
So what's the big takeaway from all this? Well, in a world that's obsessed with complicated tech, sometimes the most powerful innovations are the simplest ones. This whole story just goes to show you that radical standardization and crystal clear documentation, they really are the unsung heroes of innovation.
And that kind of leaves us with one final thought, doesn't it? We all have these little sources of chaos and inconsistency in our own work and our own lives. So if a massive factory can solve its biggest problem with just a simple checklist, what ghosts in the machine could we get rid of if we just took a minute to write down the recipe for success?